All right, now we're on R2, uncertainty in measurements. All measurements have um, levels of uncertainty, and that we just cannot be avoided. We're not God, and so we are going to have imperfections with everything we do. That's why there's a saying to measure twice and cut once for woodworkers and such. It's just literally impossible to be perfect. You might, and the difference would be for count. If you're counting how many fingers you have, there's no uncertainty. You can count. That's not a measurement, it's a count. Measurements use scales to base things on. Like we have a temperature scale. What is the temperature? We have the distance scale, where in America we use inches and feet and miles, and in the rest of the world they use meters and kilometers and centimeters and such. But you have rulers that are used to measure the size of things. So like, let's pretend I have a paperclip and I want to know how big it is. I might use a ruler to measure it. Now imagine you have your ruler at home, which generally has, rulers generally have inches and half-inch marks and quarter-inch and eighth-inch and sometimes 16th. And I have some with 64ths of inches on there, which are obviously very, very, very tiny demarcations. But imagine you have a ruler that only has inches, and each inch is that long. What would be the length of that paperclip? Well, you're going to be uncertain because the paperclip is in between 1 and 2 inches. And so you don't have a way to know exactly what it is. So it's somewhere, maybe I would guess maybe 1.5, but it might be 1 4/10. It might be 1 4 or 4.5 tenths or something like that. So it's just, there's no way to know. But if you had a ruler that had smaller demarcations, and now, okay, so what if I give you, that's a half, there's a quarter, there's an eighth, and then it continued down here, then you could make better measurements. And okay, it's not a half an inch, and it's more than a quarter of an inch, so it's definitely in between there. Maybe it's another eighth, so maybe it's 1 3/8 of an inch, so it's 1.375. Now it might be very close to that, but it might still be off. Then you might go down to 64ths of an inch, or if you had a microscope, you could go to much, 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 much smaller increments. Every time those increments get closer together and smaller, your uncertainty decreases. The highest level of uncertainty is with no standard to base the measurement on. Or in this case, when we just had 1 inch for that paperclip, it was very hard to tell what exactly its length is. And so all measurements have uncertainty. We can't avoid it, but we need to understand going forward in any science class, how do we think about the uncertainty in the numbers we're given? How do we minimize the uncertainty or maximize our certainty? All right, so we have precision, we have accuracy, and these are related but different. Precision is how close 2 or more measurements are to each other, regardless of their true accuracy. For example, water boils at 100 degrees Celsius. We know that to be true. But if you put a thermometer in boiling water, it may not show 100 degrees Celsius. It might say 99.4. And if you take another thermometer and it says 99.4, then those 2 thermometers are very precise. But are they very accurate? Not necessarily. Accuracy is how close a single measurement is to the true or known value. Now, if you had those 2 thermometers and then you added a third one, and it said 100.00000 degrees Celsius for that boiling water, that would be way more accurate than the other two. All three of them together would not necessarily be considered to be precise measurements. Obviously, you would want to use measurements that are both accurate and precise, but sometimes this is just not the case. So this drawing here kind of shows you the difference between accuracy and precision. An accurate and precise measurement has all three of the measurements in this case at the bullseye. Now in the second one here, all three measurements are close together again, but they're not at the dead center of the bullseye as in the first case. So they would be precise still because they're close together, but they're not very accurate. And then the last case here is not accurate and not precise. The three measurements are not all close together, and none of them are particularly accurate. Obviously, this is data that you would exclude if you figure out that your tools are inaccurate and imprecise.